topic of our chapter number 9, the Earth, the habitat. Let's continue. I hope you've seen the previous video sent to you all, in which we studied different concepts, different topics. Today we'll start a new topic, that is latitude, longitude. So these are two different terms used in geography, latitude and longitude. Both are different topics, okay? Both are having different meanings here, okay? They are vertical and horizontal lines drawn on the Earth's surface. They are imaginary lines. So as I told you, in geography, we will not give exact measurements. You have to imagine all these things. The measurements will not be accurate. The measurements will not be accurate. They will be approximate. Okay, students? So, vertical and horizontal lines. Okay? Vertical and horizontal lines, and both these are imaginary lines drawn on the Earth's surface. Okay? Both these are imaginary lines drawn on the Earth's surface. And why are they drawn? To know the exact time and location of specific areas, specific regions. So students, on Earth's surface you will not find in reality. Okay? These things you will not find on longitude and latitude. You will not find in reality anywhere on the Earth's surface. But in a map you can see it, and in a globe you can see it. Okay? We saw the 0 degree in the previous video, how we saw it just in the form of a line. So you have to just imagine, on the globe and on the map you can see these lines. So students, let's see both the concepts in detail. First we will see about the latitudes. Okay students, latitudes are imaginary horizontal lines drawn on the Earth's surface. Students, we have to assume, you have to imagine these things, okay, in geography. So latitudes are imaginary horizontal lines, okay? Which category of lines? Imaginary horizontal lines drawn on the Earth's surface. And these lines are drawn for specific measurements of some areas or regions. And if any point on Earth's surface is connected by a straight line, if any point on Earth's surface is connected by a straight line, then to the center of the Earth, then that line becomes the latitude of the point as far as the angle of the center is along the equator. I repeat, if any point on the Earth's surface is connected by a straight line, okay, by a straight line to the center of the Earth, then that line becomes the latitude of the point as far as the angle of the center is along the equator. For example, let's see it in the form of an example. So students, let's see it in the form of an example. See students, any point on Earth's surface connected by lines to the center to the Earth, then that line becomes the latitude of the point as far as the angle of the center is along the equator. In the previous video we saw students the equatorial line, that is 0 degree. So any point here, see, along the equator, if you have any of the places, see here students, any of the places which you can see here, then that is known as the point along the equator, that is the latitude, that becomes the latitude of that point. Okay, for example, in this you can see 0 degree here. Can you see the 0 degree here? And the places around it, see, you can see the places like Borneo, you can see the places like Maldives, along those lines. See here, Democratic Republic of Congo, all these places, okay? So along that line of latitude, 0 degree, if you have that place, then that angle becomes the latitude of that point. Okay students? And in totality students, you have 181 latitudes. How many latitudes do you have in total? You have 181 latitudes in total. Now see the next topic, that is the latitudinal line. Okay students? Now what is a latitudinal line students? When there are vertical or horizontal lines. That is horizontal line we just saw, latitude. Vertical we will be studying further stages. When these lines are connected to any point of them, we call it as latitude or longitude. But what is a latitudinal line? That is east-west circle connecting the places found on Earth in northern and southern hemisphere at an equal distance from the equator are called latitudinal lines. So students, the east-west circle, we will drawing the figures now. connecting the places found on the earth in the northern or southern hemisphere. Can be any hemisphere in the northern or southern hemisphere at an equal distance from the equator are called latitudinal lines. Okay, and it's a very simple phenomenon over here. You'll just draw this diagram along with me in your notebooks. So students, open your notebooks, write today's date, it is 30th June 2021, and write down the heading latitudinal line, and you'll draw the figure along with me. So students, we'll start drawing the figure. We'll write the heading, already I've done it, and write down here figure 1.2. First we will draw the primary basic diagram of solar system. Now we'll draw this figure for the latitudinal lines. Okay, first draw a circle in this manner. Then you have to take the exact central position of the circle. Okay students, the central position of the circle will go in this manner. Put a dot over here. Okay, and you will write 0 degree over here. 0 degree already saw in the globe, so it stands for, yes, it stands for equator. Okay, 0 degree stands for equator. And directly we will start drawing a straight line towards the central part. Okay, we elongate this line to stretch it out till the central part of the earth. So that we imagine as the earth. Okay, and to the central part will extend. And you already know in maths, when you draw it in a straight manner, it is up to which angle? Yes, 90 degree. Okay, so correct. Draw it 90 degree angle over here, right angle. You have to write here 90 degrees. So right angle is over here. 0 degree for the equatorial line is equator. 90 degree you have to draw it here. What will be studying the latitudinal lines here, students? The east-west circle connecting the places found on the earth in the northern or southern hemisphere. Anyway, students will draw the help of this diagram. For example, if you take any place here, you will have a 10 degrees, 20, 30, 40, 50, 60, like that will go. You only take for example. Okay, we'll take 2 degrees. For example, I go for 50 degrees. You already know this, you have done in geometry, maths, so 10, 20, 30, 40 goes on in this way. We'll take only one example. So 50 degrees here. Then if I take the next one, 60 degrees over here. It will go on like 70, 80, and 90 is already over here. Okay. So the places, the northern or southern, the same will come over here also. You can try this also. Here you can connect in this way. 50 degree, 60 degree. That is, it goes in the form of southern hemisphere. Here it will be in the form of northern hemisphere. Any place, way in which it goes, the east-west circle connecting places found in the northern or southern hemisphere at equal distance from the equator. See, it has to be equal distance from the equator is known as latitudinal lines. These are the latitudinal lines. Okay, students? Now, students, on page 50 of your textbook, we have a pink box in which there is an information for you. It's written there. The distance between two latitudes is actually 111 kilometers on ground. That is between two latitudes. The actual distance is 111 kilometers, okay, on ground. See, students, these are only approximate figures, okay? You have to imagine and assume these figures. Okay, now we'll come to the next topic, that is longitudes. Now, longitudes are vertical imaginary lines, okay? So, what are longitudes? Vertical imaginary lines drawn on the surface of the earth. So, they are vertical imaginary lines. What were latitudes? They were horizontal imaginary lines. But longitudes are vertical imaginary lines drawn on the surface of the earth for measurements. Okay, and they are meeting each other at poles. Where do they meet? They meet each other. Longitudes meet each other at the poles. We saw in the globe, the previous videos, the poles, North Pole and the South Pole. So they meet each other at the poles. And they come closer to each other while going towards the poles. Okay, while going towards the poles, they come closer to each other. There are total 360 longitudes. How many are there, students? There are 360 longitudes in all. So, students, the vertical lines which meet at the poles in this manner. See, this way. Okay. This is the North Pole and this is the South Pole. Okay, students. See, they come closer to each other when they meet at the pole. See, here the distance gets lesser and lesser. See, can you see this? Yes. So, in this way we can see that longitudes while coming closer, they meet each other, and while going towards the poles, north or south, they come closer to each other. And 0 degree longitude and 180 degree longitude are the most important ones for us. Okay, the 0 degree longitude and 180 degree longitude are the most important ones. Now next topic is linear circle. What is linear circle, students? Linear means connecting to a line. Okay, so the north-south straight line connecting the imaginary surface of the original linear to the Earth's axis at the same angular distance along the Earth's surface is called linear circle or semicircle. See this figure carefully, students. See how it's drawn. The semicircle, that is the line, the north-south line, straight line connecting the imaginary surfaces of the original linear to the Earth's axis at the same angular distance. Angle should be same and the same distance must be maintained along the Earth's surface is called linear circle or semicircle. Can you see the two semicircles, students? Yes. Okay. So the linear circle means the north-south straight line connecting the imaginary surface of the original linear, okay, to the Earth's surface or axis at the same angular distance along the Earth's surface is called linear circle or semicircle. In short, you can call it as a semicircle also. Now students, will move to the next topic, that is the main line. This is a very important topic for your students. This diagram has to be drawn in your books along with me. Students, start drawing this diagram with pencils. You have to label it also and start drawing it meaningfully. You have to label it as figure 1.3. Two figures we have done already. Figure 1.3 heading is main latitude. Okay students, we saw 0 degree equator, the globe. Okay, now we'll see the other important latitudes which are of much importance for measurements. Okay, so just as we saw in the previous figure, the central part, we have to imagine this as the Earth. Okay, circular portion as the Earth, this sphere as the Earth. So the exact central position, you will cut it in this manner, strike it in this manner, cut the Earth into half. Okay, students, the central part of the Earth, take it. And you have to put 0 degree over here. Okay, students, 0 degree stands for, yes, for equator. 0 degree stands for equator. That is the correct one. Okay, we saw it in the globe also. 0 degree stands for equator. See students, all these figures are imaginary. Okay, only for measurement purpose we are doing it. Okay, then you will find this in maps and in globes only. Okay, in actual real life, in reality, nothing as such is found anywhere on the earth. On the surface of the earth, you can't find all these figures. Okay, then again you have a bit above that. You have the Tropic of Cancer. It is a tropic. So here will start drawing in this way. The next, that is 23.5 degree north. Now whatever is above the 0 degree equator will be classified as north, and whatever is below 0 degree will be classified as south. And we are doing which figure, students? Main latitude. So we will put it here as north latitude in short, LAT dot. Okay, short for LAT dot. 23.5 degree north latitude, and it is known as Tropic of Cancer. What is the name, students, here? Tropic of Cancer. Okay, you have to put a slanting line. Don't draw straight lines, students. All these things are imaginary. Draw slanting line. Okay, same way, the line below the equator is classified as south. So here again, equal distance between and draw slanting waves, vary motion this way, and 23.5 degrees south latitude. Okay, here to the end there will be S. Okay, and that is Tropic of Capricorn. So you write here tropic means area, specific region. Okay, Tropic of Capricorn. Very good. Continue. Then you have your extreme poles, north and the south. Here you will have your next one. Again, you have to draw it in this manner. Students, draw the slanting line here, this way, just like a small U-shaped circular form. And here you will write 66.5 degree north latitude. Okay, and it is the Arctic Circle. What is it, students? Arctic Circle. Okay, done. Next, again in the same manner. will just give a horizontal slant line in this manner. Horizontal slant line for the tropics. Okay, just like with a dash, just like with a hyphen. And for circles, you just put in this manner, strike off. Okay, vertical lines. Okay, vertical lines. Okay, done. Have you done, students? Students, I hope you have cleared this topic. So this is very important for you all in the exam point of view, and draw it neatly. Okay. So students, how you read this? For example, 23.5 degree. Okay, this small circle is known as degree here, and here 0.5. That is 0.0, but it is known as minute. Okay, so 23 degrees, 5 minutes. Okay, 5 minutes like that. So in short, we say 23.5 degree. No, 23.5 degree south, like that we say in short. Okay. Now the horizontal line center of the earth surface is the equator, 0 degree. Then 23.5 in the northern hemisphere, Tropic of Cancer. Southern part, 23.5 degrees south, and is the Tropic of Capricorn. And so students, the Arctic Circle shows here 66.5 degree north, and Antarctic Circle shows 66.5 degrees south latitude. So 6 months for this speed of the sun. That is, you have your, now students, the speed of the sun between Tropic of Cancer in the north and Tropic of Capricorn in the south of equator is called a solstice. What is it known as? It is known as a solstice. Okay. What is a solstice, students? Solstice is speed of the sun. Okay. Between Tropic of Cancer in north and Tropic of Capricorn in the south of equator is known as a solstice. So between these solstices, you have 6 months for the speed of the sun. That is, the solstices which occur on the earth causes the change of different seasons. For example, 6 months for the speed of the sun. You have different seasons, winter, summer, monsoon. So earth is tilted at the corner at 23.5 degree latitudes. That is, when we see the globe, we can see that we are not having the shape of like a ball, we are having the shape like an orange. Why? Because earth is tilted at 23.5 degree, at the corner of 23.5 degree. So it takes 6 months for the speed of the sun in a solstice. And the sun rays fall almost straight between Tropic of Cancer and Tropic of Capricorn. Sun rays fall almost in a straight position. Now students, we will see the next diagram. Here, figure 1.4. Okay, students, this is your next diagram. Start drawing along with my notebook, students. See, the heading is iron circle. What is an iron circle, students? This diagram clearly shows the different latitudes along with the rays of the sun. How the rays of the sun are falling towards the tropics. Okay, we saw about the solstice. So how the solstice occurs. And we see this iron circle diagram. Okay, that is the minimum iron circle. How the sun rays are falling. Okay, so you have to make a sun here. Portion of sun in this sense. Just a little bit and shade in this manner with a pencil. This will shade in this manner. Okay, after shading it, write sun. Okay, written sun. Written sun, students. After writing sun, you'll start drawing the rays of the sun towards your earth. I told you the earth in a manner of a sphere you draw. You will draw any number of rays. Okay, numbers are not fixed. You can draw any number of imaginary rays towards the earth's surface. Okay, start drawing now in this manner. Rays should point out in the form of arrows. Start drawing, students. Have you drawn? Go on drawing the arrows along with me. These are the rays of the sun. Okay. The north pole and the south pole also draw the rays. Okay. Start drawing the rays. Okay. Complete in this manner. The last one, you will not draw any arrow. Okay. Complete in this manner. After that, you will start drawing the same tropics and circles which you drew in the previous diagram. So students, how you draw first? You will write here. These are the rays of the sun. Right over here, rays of sun. Labeling has to be done with pencils, students. Okay. Use a pencil for labeling. Don't use color pencils or pens. Okay. After this, you will start drawing the equator. These are the same figures. The iron circle is showing the rays of the sun, how they are falling towards the earth's surface. Okay, those are the iron rays. Okay, iron circle. Okay, we are talking of Cancer. Here you have the topic of Capricorn. Okay. Then students, you have your Arctic circle and Antarctic circle. Again, you have your 66.5 degree north latitude Arctic circle and 66.5 degree south latitude. We have your Antarctic circle. So students, you will ask, what is the difference between these two diagrams? Here you are showing the sun rays and the iron circle. That is how the sun rays are scattering towards the earth's surface. So students, we already saw about the solstice, the distance between the sun rays, how they are falling. So here, the equator is the central point. So we put an arrow for both the tropics in this way from the equator. We saw at an equal distance from the equator. We saw that in the definition. So here, again towards this tropic. So the central point is equator. The upper part, how the sun is scattered, and the lower part was the tropic of Capricorn. From the equator, how the sun is scattered. You write your iron circle. Okay, you write your iron circle. Okay, that is how the sun rays are falling towards the tropic of Cancer and tropic of Capricorn. Okay, and here again, you have to see to it that you go in this manner. That is the circles. You have your vertical lines, and here you have your horizontal lines right now in this manner. Okay. Okay, students. So this was the iron